All right, let's look at homework 11, problem number 3. And let's just do part A. All right, so it looks like the differential equation is already given here. And the right-hand side, it says that E0, which is a constant, right? And you have initial value given there, right? So let's do that. All right, so you have, let's see, I don't like having R here, so I'm going to just divide the equation through by, say, R. So divide through by R. And we'll get Q prime plus 1 over RC. Then you have a Q is equal to, right hand side, remember it's just a constant E0 divided by R. Right? So we can just do an integrating factor. So I'm going to call it I of t, right, which is going to be e to the integral of p of t, right? P of t in this case is this guy, right? Which is just a constant. So it's a 1 over RC with respect to t. Right? So this will give you e to the t minus RC. Right? So so we can find the solution Q of t. So Q of t, all right, and it's equal to, let's see, reciprocal 1 over I, so it's going to be e to the negative t over RC, right? Then integral, and the right hand side is just E0 over R times integrating factor, so e to the t over RC with respect to t, right? So this is going to be equal to, all right, so you have e to the negative t over RC and E0 over R. All right, so then antiderivative of that would be e to the t over RC over 1 over RC is multiplied by RC, right? Then you have a plus some constant CC or something like that. So I need a parenthesis right here and there, right? Then you can cancel things out. Let's see, so we can cancel all on the bottom, all on top, canceled out. All right, then let's try to distribute things. So I'm going to distribute this guy right here to each term. So this guy and also that guy, right? So what you get is, this is equal to, right? Then, oh, actually, can I put the C1? Because I might want to call it differently. All right, so it's, if you distribute that, so these are reciprocal of each other, you're going to get 1. So you're going to get E0 C times 1, right? Plus C1 e to the negative t over RC. Right? Then I'm going to just factor out the constant, so we have E0 C, right? Then you have a 1, right? Then you have a C1. I guess if you factor it out, you have to divide. So E0 C e to the negative t over RC. Right? So there's no point of having this complicated constant here. So I'm gonna call this guy C2, right? So basically what you get is Q of t is equal to E0 C. Then you have a 1 plus C2 e to the negative t over RC. Right? So we need to find the C2. So we can use this initial condition here. Right? So we can plug in 0 for t. Then you see that if you plug in 0 here, it's going to be 1. So E0 C 1 plus C2 times 1. So this is supposed to be equal to 0. Alright, so which means that the C2 must be negative 1. Right, C2 is supposed to be negative 1. Right, so therefore, we found our Q of t, which is going to be E0C times quantity 1 minus e to the negative t over RC. Right? So looks like we got the right answer. So we have that right there. Right? Then, oops, there's a typo there. So I meant I, right? So I. Right? So I can be found by doing this. Remember that the current is simply the derivative of the charge. Right? So you just take the derivative of that, and I think you can do that on your own. Right? That's it. I hope that this will get you going.